You give your new AI assistant a simple command: clear out my inbox and schedule my upcoming meetings. Beat. You naturally expect, a bit of seamless digital magic.
Right, yeah. You expect it to just work.
Exactly. But an hour later, your calendar is completely double booked. Your important emails are just a total garbled mess.
A total disaster.
Yeah, the automated workflow looks like tangled Christmas lights. The whole system just collapses under its own weight. 2 sec silence. It leaves you completely frustrated in the dark.
Oh, absolutely. And I mean, that is the exact reason most people quit. Building a reliable AI agent feels totally impossible sometimes. It's incredibly frustrating when everything keeps mysteriously breaking.
Welcome to our deep dive for today. We have a very clear mission today. We are unpacking a definitive blueprint from March 2026.
It's a great one.
It really is. This technical guide was written by Max Anta. He shows you how to build a persistent assistant, an unstoppable AI system built right inside n8n. And you do it without writing a single line of code.
Yeah, it's a truly brilliant technical journey. We're going to explore moving away from those fragile giant workflows. Instead, we adopt a robust hub-and-spoke architecture. We give the AI a dedicated memory. Then, we hook it directly up to Telegram.
Which gives it voice control, right?
Exactly. Seamless, real-time voice control.
Okay, let's unpack this. Beat. I want to start with that tangled mess of Christmas lights. Most beginners make a very specific, fatal mistake initially.
The all-in-one approach.
Right. They try to chain everything into one massive linear workflow. Email, calendar, web search. It all lives in one single sequence.
Yeah, and it works perfectly for maybe like 3 or 4 days.
Yeah.
But then one small thing changes in an API somewhere. Suddenly, the whole monolithic system just crashes. A linear chain is only as strong as its weakest link.
If I'm looking at this hub and spoke model, my first instinct is actually quite skeptical.
Oh, really? How so?
Well, it seems like adding all these separate sub-agents creates more failure points. More independent nodes just mean more potential problems, right?
You would naturally think so. But it's actually the exact opposite in practice. By embracing the hub-and-spoke architecture, you isolate those failure points entirely.
Okay.
It's basically a central brain that routes tasks to smaller, specialized helper bots. It directly mirrors how software engineers build modern microservices. If your calendar bot breaks, your email bot still works perfectly. The technical problems stay completely contained.
It's basically like hiring a highly intelligent CEO.
Yeah.
Beat. The central AI routing brain is your smart CEO.
I love that analogy.
Right. They delegate specific tasks to highly expert internal departments. The CEO does not do all the tedious grunt work themselves. They simply evaluate the request and route the paperwork.
Exactly. A CEO trying to do everything always fails eventually. An AI agent holding 20 different tools gets severely confused. It starts calling the wrong digital tools almost immediately. It just collapses under its own cognitive weight.
That makes perfect logical sense when you consider it. 2-sec silence. But what exactly causes that technical degradation? Like, exactly why does that all-in-one approach fail so quickly in practice?
Because every added node creates competing operational logic pathways. When you overload one agent, its core decision-making logic scrambles. It simply cannot maintain strict focus on a single objective. You need a central brain that strictly just routes digital traffic.
So, isolate the tasks to stop one error from breaking the whole system.
That is the ultimate golden rule of reliable system design.
Okay, so a great organizational structure absolutely needs a powerful CEO. Let's look closely at the central brain of this operation. How does this orchestrator actually connect to the outside world securely?
Well, every AI system needs a reliable digital front door. For this setup, that front door is the Telegram app.
Telegram.
Yeah, it acts as the initial trigger node for incoming data. You get a secure token from the Telegram bot father. Then you verify the initial JSON data handshake process.
The JSON handshake proves the assistant is actively listening. Beat. Once that secure door is open, we add the central intelligence. We drop a specialized AI agent node into the n8n canvas. This specific brain is powered by the GPT-5.4 Nano model.
And what's fascinating here is the choice of that nano model. It boasts 300% faster tool calling latency speeds.
Wow, 300%.
Yeah, compared directly to the older 4 Series AI models. Speed is absolutely everything when building a central orchestrator agent.
It receives the message and processes the user intent instantly, then it quickly passes it to the AI model.
Yeah.
But we need a very solid core system prompt here. I still wrestle with prompt drift myself, where the AI just forgets its core instructions.
Oh, we all do. It's so frustrating.
Just last week, my agent forgot it was supposed to draft emails. It started writing me complex Python code instead. It just loses the plot entirely without strict instructions.
Right. Prompt drift is a massive headache for everyone. That is exactly why the central prompt needs one strict rule. You must enforce the one tool at a time rule. If you ignore this, you instantly get race conditions.
Race conditions. What does that mean exactly?
Systems crashing because tasks try to finish at the exact same time.
I see.
Yeah, the nano model often tries to be way too efficient. It attempts to call two distinct tools in a single turn. Like, it wants to fetch an email and check the calendar simultaneously.
Let me picture this structurally for a moment.
Yeah.
What physically happens to the output when an AI model attempts to call multiple tools simultaneously?
Think of the n8n workflow like a single-lane bridge.
Hmm.
If the AI fires off a command to check your calendar, and a millisecond later fires off an email command, both tools try to drive their data back across that single-lane bridge.
At the exact same time.
Exactly. The data streams collide violently inside the n8n interface. The system cannot sequence them correctly, so it just returns a scrambled error.
Got it. Rushing multiple tools causes data collisions and breaks the output.
Precisely. Forcing a strict one-tool rule acts as a necessary traffic light. One single call, one specific response. It keeps everything perfectly stable.
But a brain that works fast is ultimately useless in isolation. Beat. It is completely useless if it forgets who you are immediately.
Oh, absolutely. We have to cure the AI amnesia problem. Otherwise, it treats every single message like a brand new conversation. You'd have to constantly re-explain your specific personal preferences.
That is not a helpful assistant. It is a goldfish. Beat. We fix this digital amnesia with a window buffer memory node.
Right. This node connects directly to the AI agent's memory slot, but the crucial detail is scoping the memory properly. You must scope it strictly to the Telegram chat ID.
That separates the conversation memory by each specific user. Beat. If multiple people use the bot, their data does not mix. Your calendar requests do not bleed into my email drafts.
Exactly. Next, we set the memory window size very carefully. You set the window size to exactly 10 recent messages.
We also need a very lightweight contact manager. We use Google Sheets as a simple, hard-coded database. It just holds the contact name, email, and phone number.
The simplicity of this approach is the true genius part. You instruct the AI to check the Google Sheet first.
Before it does anything else.
Right, before sending any outgoing email draft. That turns a basic spreadsheet into a dynamic relationship manager.
It reads the spreadsheet file directly without any fuss. No bulky, expensive CRM software is required for this setup. Hard-coding a simple JSON pull from Google Sheets is computationally cheaper. It is much faster for Nano than pinging a bloated Salesforce API. 2-sec silence. But I have a question about that memory limit. Why is the memory window capped at exactly 10 messages, rather than letting it remember the entire history?
Well, because feeding massive chat histories into the prompt eats up tokens rapidly. It forces the AI to process irrelevant historical data constantly.
Which slows it down.
Drastically. It slows down every single interaction. 10 messages provide enough context without sacrificing that blistering nanospeed.
Right, it keeps the AI context-aware without slowing down the processing speed.
Exactly. It stays perfectly coherent and still runs blazing fast.
Okay, so we have a brain that remembers who you are. It processes your complex commands instantly. Sponsor. But a brain in a jar cannot actually clear your inbox. It needs authorization to touch your outside tools. How does this orchestrator actually cross over into Google's ecosystem securely?
This is where we build those highly modular, completely independent subagents. These are the specialized expert departments your CEO delegates to.
All right.
First, we have the specialized email subagent tool. It's a standalone workflow strictly connected to Gmail nodes.
The main agent does not write the email itself. It just sends a text memo to the email subagent. Beat. Then we have the highly useful calendar subagent. It directly connects to your personal Google Calendar account. But this specific agent carries a very crucial warning.
Yes, it really does. You need incredibly strict confirmation guardrails in the system prompt. Otherwise, it might accidentally book a random external meeting.
Just from a casual text.
Yeah, exactly. It could happen just because you casually mentioned a random date in chat.
It absolutely needs a mandatory user confirmation roadblock programmed in. Beat. Next is the very powerful research subagent tool. This specific tool completely beats the standard AI knowledge cutoff limitation.
It does. It pulls fresh data from 3 live internet sources. Wikipedia provides incredibly solid background facts and historical overviews. Hacker News gives you raw tech community discussions and trend analysis.
And the Serper API.
That handles the live Google search web results natively.
3 highly distinct sources, 3 highly distinct data strengths. Beat. But if these departments are totally separate workflows, how does the main brain actually know which subagent to pick for a given task?
It relies entirely on clear, literal text descriptions you provide. You write these descriptions directly on the call n8n workflow node. The Nano model reads that plain text to decide perfectly.
It just reads the label.
Exactly. It reads, use this for scheduling, and routes it to the calendar.
The text description essentially acts as a logical routing map. 2-sec silence. But I am still slightly worried about those calendar guardrails. How do we ensure the AI actually respects those guardrails instead of acting on its own?
You family hard-code the rule into the calendar agent's system prompt. You explicitly state, always ask the user to confirm before creating the event.
So it's hard-coded.
Right. It simply cannot bypass that explicit systemic instruction. It creates a hard programmatic stop.
Make the confirmation step a mandatory roadblock in the subagent's core system prompt.
Yes. That prevents extremely disastrous automated scheduling mistakes from happening entirely.
Texting a highly capable digital assistant is certainly great. Beat. But typing out long commands still feels like traditional software interactions. Actually talking to one out loud in real time, that is where this system feels like absolute magic.
Oh, this part is amazing. It beautifully integrates two-way digital audio functionality. It makes the digital assistant feel truly and remarkably human. It all starts with a simple switch node in n8n.
The switch node smartly routes all incoming Telegram messages. Standard text messages go straight to the main AI agent directly. Incoming voice files are downloaded first for dedicated audio processing.
And we use OpenAI's incredible whisper model for this specific step. It transcribes the user's spoken audio into text perfectly. Then it passes that transcribed text directly to the central brain.
Then the AI brain generates a standard text response.
Wow.
We use a custom HTTP request to send it to 11 Labs.
Right. 11 Labs converts that text back into incredibly high-quality audio. Then it sends the audio file back via the Telegram app, Beat. Whoa. Imagine scaling this to process 1 billion queries. It completely changes human-computer interaction forever.
Here's where it gets really interesting for everyday users. Beat. There is a massive psychological shift happening right here. You are getting a highly natural voice note back. It's coming directly from your own personal data architecture.
It shifts your brain entirely. You go from using a flat tool to having a dynamic conversation. You speak naturally to it. It speaks naturally right back. It bridges the digital divide completely.
It truly feels like holding the future in your hands. 2-sec silence. But I have a real logistical concern here regarding speed. Does adding 2 API translation layers, audio to text, then text audio, cause a frustrating delay for the user?
Well, you would naturally think so when looking at the architecture. Those extra API hops usually create a terrible processing lag. But remember, GPT-5.4 Nano has that 300% faster latency.
Right.
It churns through the complex routing logic so incredibly fast. The total round trip still feels totally conversational and natural.
So the Nano model's sheer speed makes the audio conversion feel totally seamless.
Exactly. That raw API speed creates the perfect illusion of human presence.
As incredible as this automated digital setup truly is, Beat, there are always a few hidden potholes that can derail the whole thing. The devil is always in the deployment details.
Yeah, system errors usually come from missing rules or poor initial setup. One incredibly common workflow issue is incorrect calendar event times. You must set your n8n time zones correctly so events align properly.
Yes, 9 a.m. comes midnight.
Exactly. If you skip that, your 9 a.m. meeting suddenly books at midnight.
Another very common issue is the voice transcription step failing completely. Telegram-style URLs tend to expire extremely quickly by default. You must use the native Telegram GET file action instead. That ensures the audio data does not simply disappear mid-transfer.
Yep, these small technical configuration details completely control overall system reliability. But let's look closely at the ultimate payoff here. It is a concept called agentic modularity.
Agentic modularity.
Indeed.
Building independent AI tools you can plug into any future project.
Perfect definition. If we connect this to the bigger picture, it changes everything. The real advantage belongs to people building libraries of reusable systems. You are not just using simple one-off automated tools anymore. You are creating permanent digital assets.
You build the core system once. Then you just reuse it everywhere. Beat. Think about that email subagent we just built. Tomorrow, you could plug that exact same agent directly into a customer support bot.
Yeah.
Or you could plug it right into a lead generator.
Right, without rewriting anything.
You do not rewrite a single workflow node.
You just quickly drop the module right into the new workflow. It instantly inherits all the hard work you already did previously. Your personal digital library keeps growing massively over time.
It is a truly profound shift in technical thinking. 2-sec silence. But this requires a completely different approach to building software. What is the biggest mental hurdle for a beginner trying to adopt this modular mindset?
It is definitely the overwhelming urge to just get it done quickly. It takes slightly more effort today to build a separate, isolated subagent.
It feels like extra work.
Yeah, but if you give in to the lazy all-in-one approach today, you rob yourself of tomorrow's incredible technical leverage.
Stop building for one task. Start stacking Lego blocks of data for tomorrow.
Beautifully said. That is the absolute secret to safely scaling personal AI systems.
So what does this all mean? Beat. By permanently moving away from brittle giant workflows, we win. Embracing a highly modular hub-and-spoke model with GPT-5.4 Nano creates a robust ecosystem. You use the Telegram app as a perfectly seamless UI.
You carefully scope distinct conversational memory strictly to the individual user. You strategically build completely standalone, specialized task subagents. The ultimate result is a digital employee that actually works flawlessly.
It entirely changes how you manage your complicated daily life.
It really does. And, this raises an important question about the broader future. If an individual can build an unbreakable, modular AI library for their personal life over a weekend,
Yeah.
what happens to traditional corporate software when every employee has their own custom-built, highly specific ecosystem of sub-agents doing the work of 10 people?
That is a truly staggering thought about the future of work. Beat. But you have to start somewhere. Do not try to build the entire complex system today. Just take a moment and sketch out your very first subagent. What is the one tedious task you would outsource to your own digital specialist?
Start incredibly small. Build that very first data Lego block today.
Soon, you definitely won't be untangling those Christmas lights in the dark anymore. You will simply ask your perfectly built AI system to turn on the lights for you. Beat. Thank you for joining us on this deep dive. Keep building the future. Out T-Row Music.